Okay, so this first homework question from 2.5 was asking you to find the second derivative, which the notation looks like this. So first we need to find the first derivative with respect to x because it has dx on the bottom. So for both of these, I'm going to take the derivative with respect to x. This is going to be 2x, and then this is going to be 2y, but then I need to have a dy dx because there's a y there and it's with respect to x. And then the derivative of 36 is 0. Please don't forget that. I do need to get the dy dx alone before I can do anything, so I'm going to subtract 2x from both sides. And then I'm going to need to divide by 2y to get the dy dx alone. Okay, and that's going to simplify. The 2's are going to divide, so actually I just realized I left the negative off, so it was negative 2y. So I get x over y for my dy dx. Now I need to find the second derivative, so I need to take the derivative of this. Again, with respect to x, so if I'm taking the derivative on both sides with respect to x, the derivative of this dy dx is just going to be the second derivative. It's going to look like that. And then over here, I'm actually going to have to do the quotient rule. So we have x and y. So I'm going to have, I wrote that backwards. I don't know why I did that. Okay, so low and high. So I have y times 1 minus x times, and here's where we need to be careful. So low d high, so that's y times 1, minus high d low, so I have x. The derivative of y is 1, but don't forget I have to have that dy dx term. And then it's all over low, the denominator squared. It's going to look like that. So the thing is, if I'm actually trying to find dy, or like the second derivative, I need to plug in what I know about that term right there, that dy dx. Remember, that actually is x over y. So I'm going to have, y minus, and so in here I'm going to plug in x over y. So it's y minus x times x over y, all over y squared, and I have to do some simplifying here. Keep zooming in and don't mean to, sorry. So now I have y minus x squared over y, all over y squared, and that really is the answer. Like, you can leave that on a free response, but on a multiple choice you would likely need to be simplifying this a little bit. And so probably the easiest way would just be to multiply everything by y over y, because that will get this denominator out. So then I'm going to have y squared minus x squared all over y to the third. And that is the second derivative. Okay, so I was going to jump on to number 55, but it actually is about normal lines, and I think it would make more sense to do 53 first, just for the sake of talking about it. So 53 asks you to find the tangent line and the normal line at these 2 points. And then it does go on to say in the directions that a normal line is a point that is perpendicular to the tangent. So we do need to remember something about slope here from our algebra days. If two lines are perpendicular, that means their slopes are opposite reciprocals of each other. Okay, so first things first, of course, if we're trying to find a tangent line, we need a slope and a point. And we have the points, so that's easy. So now we just need the slopes. So to get the slopes, we need to take the derivative with respect to x of both of these things, or both sides, that is. And this keeps coming up, but this is a circle. I'm going to draw a picture of what's going on here in a minute too. But that is a circle with a radius of 5. So the derivative of this with respect to x is 2x. The derivative of this is 2y dy dx, because of the chain rule. And the derivative of 25 is 0. If I solve this for dy dx, I'm going to subtract that 2x, and then I'm going to divide by 2y. And I'm going to have this, and that is negative x over y. Okay, so that's the slope of the tangent line. So when the point is 4, 3, the slope is negative 4 over 3. And then when the point is negative 3, 4, the slope is positive 3/4. So again, this is just tangent line. I haven't done anything like perpendicular yet. So the first part of this is pretty easy. I'm going to use my normal like point slope form. So y minus 3 equals negative 4/3 x minus 4. That's the tangent line to 4, 3. And then for this one, it's still going to be y minus 4, but it's going to be 3/4 x plus 3. So these are the tangent lines. And I do kind of want to draw a picture just so you guys can be picturing this. So as I mentioned, like that equation was the equation of a circle with a radius of 5. We'll pretend that those are even. And 4, 3 is about here. So we just found the equation for that tangent line. Pretend that's straight. And then also for negative 3, 4, which is going to be like here. And that was not very good. There you go. So we just found the equations for those two lines. Okay, I just highlighted the ones that are, just so you can see which one goes with which. Now, when it asked about the normal line, that is just literally like it's the same equation except a different slope. So this red one is talking about this line right here that I just drew, like with the highlighter, that perpendicular line. So I take that equation right there, and I'm going to keep the same, like y minus 3, and it's still going to have x minus 4, but the difference is the slope is going to be positive 3/4 now, because I'm going to reciprocate this slope up here that I just circled. Reciprocate it and make it the opposite. That makes it normal. And then for the yellow one, I'm writing the equation for that line right there that's perpendicular. Excuse me. And I'm going to keep the point the same, but then I'm going to reciprocate and change the sign for the slope. So these two are the normal lines. Yes, I thought it would be good to go over this one because 55 is about like kind of a proof about normal line stuff. Question number 55. Show that the normal line at any point on the circle x squared plus y squared equals r squared passes through the origin. I actually really like this question because it's kind of getting us back to something that you learned in geometry, which was basically, I guess we don't need it. If you have a circle, there was actually like a rule, that you just kind of memorized, but it said that the radius is always perpendicular to the tangent line. So no matter where you drew a tangent line, if you connected it to the center of the circle and made a radius, that it was like always perpendicular no matter where that tangent line was. So I can draw a tangent line anywhere and connect it to the center, and it's always going to be perpendicular. So that was actually something that you just memorized when you did geometry. But now we can actually prove it, which is awesome. So here's what we've got. Okay, so we need to take the derivative because if we're talking about a normal line, we kind of need to figure out what the slope is when you have a normal line. So you're going to take the derivative of this function, but with respect to x. Try to clean that up a little bit. Nope, still didn't work. Okay, we'll just pretend that that makes sense. Okay, so I'm going to take the derivative of this whole thing with respect to x. And notice we're like doing this with the general form of the equation of a circle. And so this is going to prove like that this is the case for all circles because there's no numbers in here. Okay, and you've taken the derivative with respect to x for a circle many times. You've got 2x, 2y, plus 2y, dy dt, or sorry, dy dx equals 0 because r is a constant in this case. R is the radius. It is not changing, so we know that r is a constant. I'm going to solve for dy dx. I'm already in related rates land. By subtracting 2x and then dividing by 2y, I get negative x over y. Now this is actually the slope of the tangent line, and this is asking me about the normal line. So I need to find the slope of the normal line. And that's going to be the opposite reciprocal, which is y over x. Okay, and here's where we have to kind of take things into account. So this is saying like at any point. So let's call our point just like x naught and y naught. Like that's our point that this is going through on the circle. We could kind of put anything, but we're just using general terms here. So if I'm doing the point slope form, I'm going to have, and I'm going to plug in my y naught. And actually, since I'm talking about the slope, like at this point, my normal line slope is going to be y naught over x naught. Like we would actually plug those numbers in, just like we did on the last problem, where we plugged the point into our slope to actually get what it is. So I have y naught over x naught for my slope, and then I have x minus x naught to finish out the rest of my equation. This is the equation for all normal lines to the, like normal to a tangent line that's on the circle. They ask specifically to prove why it's always going to go through 0, 0. So to prove that this line is always going to go through 0, 0, I'm going to plug 0, 0 in. And remember that y naught and x naught are like, they're just representing like a point that is on the circle. So like those are numbers. So I'm trying to show that this line goes through 0, 0. And when I work this out, I have 0 minus y naught equals y naught over x naught, and then 0 minus x naught. And 0 minus x naught is just negative x naught. And so notice when I simplify this using algebra, I end up with negative y naught. And then right here, x naught and negative x naught end up dividing out or canceling, and I get negative y naught. So I have negative y naught equals negative y naught, which is always true. So we just proved that like no matter what point you're at on the circle, if you have a tangent line at that point, its normal line is always going to go through 0, 0. It's always going to go through the origin. Third term is, third term going to be 200, if I can get back to my page. Okay, on this last one, I haven't worked it out ahead of time, so this is a little dangerous, but it asks us to find all the points at which the graph of the equation has a vertical or horizontal tangent line. It did say points, so I want to make sure that we remember at the end that we're actually finding points. But if we're finding like vertical or horizontal tangent lines, we need to know we need to find the slope. That's basically like undefined slope or 0 slope. So we need to take the derivative of both sides with respect to x. And we'll just kind of walk through each thing. So the derivative of the first term with respect to x is 50x. The derivative of the second term with respect to x is 32y dy dx. Because again, remember, it's like this y is on the inside and I'm doing chain rule. And the derivative of this next term is 200. And then I have minus 160, because the derivative of that would be 160, and then I have to do chain rule, so I have dy dx. And then the derivative of 400 is 0, and the derivative of 0 is 0. So here is my equation. In order for me to do any of this, I need to isolate dy dx. So I need to get all the terms with dy dx on one side, which they kind of are already. And then I need to get the things that don't have dy dx onto the other side. Okay, so I have terms without dy dx on the right and terms with it on the left. Now I'm going to factor dy dx out of this term. And I'm left with 32y minus 160 equals negative 150x minus 200. And to solve for dy dx, I'm going to have negative 50x minus 200 divided by 32y minus 160. Okay, now that represents the slope at any point x and y on the graph. Okay, so here's the thing that's kind of interesting. And this, again, remember it asked for points where there was a horizontal tangent line or a vertical tangent line. Horizontal tangent line means that the whole slope is 0, which if this whole slope equals 0, that really just means the numerator equals 0, because, 0 divided by anything is 0. So I'm going to just set the numerator equal to 0 and solve. This will help me to find horizontal. I'll add 200 and then divide by negative 50, which gives me negative 4. Okay, but the thing is, so there's a horizontal tangent line at x equals negative 4. That is not a point. That is just part of a point. So I'm going to have to plug that into the original to actually find what the y value is. But maybe before we do that, let's find where it's going to be vertical. So a vertical tangent line is going to happen when the denominator equals 0 because it's undefined. So I'm going to set 32y minus 160 equal to 0 because that's the denominator. And if it equals 0, then it's going to be undefined. So I'm going to add 160 and divide by 32. And I get 5. So basically, I need to figure out what the point is when x is negative 4, and I need to find out what the point is when y is 5. So I'm going to have 2 different points. So I actually have to go back to the beginning of the problem and look at the original equation. This part is going to be annoying. So there's the original problem. I need to plug in my numbers here. They're going to get rather large. You might hear Zeke singing. It is currently an hour past his bedtime, and he is still in his bed just singing. Okay, here's where I am so far. I just evaluated what I have so far, which is kind of interesting because I have 400 and a negative 800 and then a positive 400. So those actually end up canceling out. And I have 16y squared minus 160y equals 0. And if I wanted to solve this, I would need to factor. They have a 16y in common, which would give me y minus 10 here. So now that I have it factored, I can set each factor equal to 0. And so 16y equals 0. And the reason I can do that is because it's multiplication. And anything times 0 is 0. So I have y equals 10 and y equals 0. So again, remember the x that I plugged in was negative 4. So at negative 4, 0, and at negative 4, 10, we have horizontal tangent lines. Because remember, at negative 4 is where we found that the slope was 0. So now I need to do the same thing, except I need to plug in 5 for y. Okay, so notice I have the same equation as I did at the very beginning, except this time I've put 5 in the place of y. I need to actually simplify this out. Okay, so funny enough, this is 400 and that's negative 800. So again, when I add up all of those, they actually end up canceling out. So I have 25x squared plus 200x equals 0. And I can factor out a 25x. So I'm going to have x plus 8 equals 0. And they are factors being multiplied, so I can separate them and set them equal to 0. And I get x is 0 and x is negative 8. And remember, the y value that I plugged in was 5. So what we have just found is that it has a vertical tangent line at the points 0, 5, and negative 8, 5. I really hope those are all the right answers. I think they are.